discrete uniform distribution. Okay, the definition of discrete uniform is A with respect to x is the discrete uniform distribution over 1 till n, written as x as an element of unit 1 to n if p of x equal to 1 divided by n, where you have x in an element of 1 to n. Okay. The proof is that let x be in 1 to n, then e of x is equal to nh divided by 2. Variance of x is n squared minus 1 divided by 12. Okay. The proof is that for r is equal to 1 to this, e to the power of x of n is equal to summation of I is equal to 1 till n, where I of r1 by n equal to 1 by n plus 1 divided by 2 if r is equal to 1 by n plus 1, 2n plus 1 divided by 6 if r is equal to 2. Okay. There's something called hypergeometric distribution too, which basically talks about the fact that there is a finite population n, okay, and then you have type 1, which is m, type 2 n minus m, okay, and you draw a random sample of size n without replacement. Okay, where x is nothing but number of objects of type 1 in the sample. Okay, then x its h is said to have, okay, a hyperparameter distribution with parameters m, n, and n. Okay, you can also write this thing down as x with hpy, m, n, and n. Okay. So when you say that x is having a hyperparameter distribution with n, m, and n, the PMF, which is the probability mass distribution of x, is going to be written as P of x equal to x, m of x, n minus x divided by n of n, 0, okay, where x is equal to 0, 1 till n, otherwise. Okay, so the remarks that you can write over here is that note that P of x equal to x may be 0 for certain x and an element of 1 till n, for example, where P of x equal to x, 0, 0 and m, m of x equal to 0, where x is an element greater than or equal to m, where x 0 n shows the min, where x equal to m n, and this where n minus m, n minus x equal to 0, n minus x, n minus m, m plus n minus n is greater than or equal to x, where x c is plus n minus 1 the way of n. Okay. You can prove this. I don't want to go and prove all of that stuff. Like, that's going to take a longer time. But that's what it is. Let's go into the details of something called the binomial distribution. Just going to cover that. So what is binomial distribution? Binomial distribution only has like two outcomes. Okay. Let's consider it to be S and F, which is success and failure, with P of S equal to P in an element of 0 to 1. Okay. Suppose that you're carrying out an experiment with n number of times. Let's say, suppose that the experiment is repeated n times independently. Let x be all the element in S in n trials. Okay, then x is set to have the binomial distribution with the parameters n and p. Okay, the notation that you can have over here is that x with binomial and p. Okay, you can prove this. I think if you want to see how the proof goes, like if you can consider p of, which is p of x equal to x. Let's say the formula that is given, the PMF for the binomial distribution is this. This is the formula that you should remember. x0 1 till n, 0 otherwise, right? So if x is in the element of 0 1 till n, p of x equal to 0, p of f till f, p of f to the power of n is nothing but 1 minus p to the power of n, where p of x equal to 1 is p of sf till f union f. It keeps going like this, where you have all these proof. N of p of s, p of f n minus 1, and p 1 minus p to the power of n minus 1, p of x equal to x. Right, so that converts into n factorial, x factorial, n minus 1, x factorial.